In this video, we'll talk about analyzing whether or not a series converges using the integral test. We want to determine if the series given here, n from 4 to infinity, of n squared divided by n cubed plus 4 all to the fifth power, converges or diverges. And we're going to do this using the integral test. That's the only test we have at this point to determine whether or not something converges or diverges. So what's the main idea of this test? This idea is I'm going to replace the sequence that is in the series by its corresponding function. And if that improper integral for that function converges, so does the series. And if that improper integral diverges, so does the series. So our sequence inside here is an, which is n squared over n cubed plus 4 all to the fifth power, which means I define the function f of x to be x squared over x cubed plus 4 all to the fifth power. And I'm going to look at the improper integral from 4 up to infinity of x squared over x cubed plus 4 to the fifth. And to work this integral out properly, we're going to replace the upper limit infinity by an r, and we'll send r to infinity. We can solve this integral using substitution. We're going to let u be that part in the denominator, x cubed plus 4. So then du is 3x squared dx, and I see my x squared here up top, which I want to be there. So then when I rewrite this integral, it becomes the limit as r goes to infinity. Integral of 4 cubed plus 4 is 68 up to r cubed plus 4 of 1/3 1 over u to the fifth. I can then integrate. Gives me a negative 1 over 12 u to the minus 4 from 68 up to r cubed plus 4, which looks like the limit as r goes to infinity of negative 1 over 12 times r cubed plus 4 to the fourth plus 1 over 12 times 68 to the fourth. And as r goes to infinity, this term here goes to 0 because we have r in the denominator. That's going to make it, let's make the denominator really, really big, and so the whole thing goes to 0, meaning this equals 1 over 12 times 68 to the fourth, which tells us this integral converges. Therefore, we know that by the integral test, the series also converges. So therefore, since the integral from 4 to infinity of x squared over x cubed plus 4 to the fifth dx converges, the series of n squared over n cubed plus 4 to the fifth also converges, which that determination of the problem asks us to do. Now, note that this does not tell us that this series equals the same number we had up here. All the integral test tells us is that if the integral converges, so does the series, but not they converge to the same value. So I do not know, and in fact it's not going to be true, that this value here is actually that 1 over 12 and 68 to the fourth. But we will know for a fact this series does converge, which is nice to know when we're trying to evaluate things using series.